You say okay then.
Okay. We did eventually come up with a model that we felt would work and give us something to use to show some interesting data analysis for this presentation. So here are the different variables we came up with. Diabetes is our dependent variable, as you can tell from the very first slide there. After that, we did use personal income, which the numbers were way too big to use on their own, so we had to take the log transformation of that variable. Other than that, we used family size, age, high blood pressure diagnosis, high cholesterol diagnosis, asthma diagnosis, and I thought there was one other, but I think I might have missed it on our chart here. Sorry about that.
These are actually this one, no, not this one. This one, this one, and this one are all class variables, or yeah, they're class variables.
They were yes or no variables, and one thing about these variables here is there was on the observations they used one that was not applicable. When they were going through their questions, they actually said they skipped certain ones when they were asking different individuals. So the only way we could actually get it to work without blowing up our model was just to remove those variables and then try to work with what we had after that.
Yeah, this is just a frequency table. One was they do have diabetes, and two is they do not have diabetes. And we're showing this because we ran a logistic regression to show the odds of someone having diabetes. 284 with, and 2,690 without diabetes.
Which I felt like was a pretty good ratio there. Not bad.
So it's about a 10% rate of diabetes. It's kind of high.
Yeah,
Could it be worse?
it could be that. Here we just have the our p-value chart, which since I'm not sure if you all know what p-values are, p-values are the. I should explain this to you.
Okay, these are the percentages. These are probabilities of p-values of probability that holding all other value or variables constant. How did I explain that before? Sorry, now I'm lost. You got it?
P-value is the how far away, what's the chance of each of these variables happening, holding every other variable constant. So, like physical activity, its chance, so it's down fairly low p-value there, so very significant of physical activity being a good predictor of diabetes, holding every other variable here constant. So it's null would be that it didn't do anything to predict diabetes, and this is how far away from that null it is. But we have
One interesting one is asthma. It is completely irrelevant. Almost 100% irrelevant in predicting whether or not someone has diabetes. We just thought that was interesting.
It isn't.
Yeah.
it almost seems like you could say if you have asthma, you're not going to get diabetes. So that's one good thing. If you have asthma, you don't have to worry about getting diabetes. But another one that we wanted to point out was going to be the family size. It actually was a significant variable. We weren't quite sure. We threw it in there to see what it would come out with, but it was a significant variable there. But we did not look into which direction it was significant. So it could have been that the larger families have a higher chance of getting diabetes, or the smaller families have a chance of getting diabetes. But it is a significant variable. We did come up with a final model of the log odds of diabetes here, which is just taking from our previous chart there and putting it onto a plus or minus with the multiplication of said variables. Again, you see the actual point estimate of ASMO, which is why the p-value was so large. Here's just the odds ratios, which odds ratios is based off of the dependent variable of diabetes, which would be something you were going to explain there.
This odds ratio, so for this one, someone with, so this is the variable that's being compared against the second one. So second, a 2 was, it does not do physical activity on a consistent basis. So if you do consistent physical activity, you are 0.636 times more likely, I guess, to get diabetes than someone who does not do physical activity. And said asthma is 1, it's its point estimate, so it literally does not do anything. A big one was high blood pressure. So if you have high blood pressure, you're 3.5 times more likely to get diabetes than someone without it.
The number less than 1 means it's protective.
Yeah.
And I was actually surprised at the body mass index, as low as that was. I expected that one to be higher, just because typically, I mean, obviously there's different types of diabetes, but more than anything from like previous knowledge, I had figured bigger people had more diabetes, but that's.
Yeah, I don't mean to interrupt, but I'll ask this question now instead of saving it for the end, but that BMI variable, is it a continuous variable?
It is continuous.
Okay. So what you're seeing there for that point estimate is for a 1 unit change in BMI, you're 1.07 times more likely, right? So that means like you go from a 25 to a 26, but multiply that by 10, and you go from a 20 to a 30, now you're getting a pretty big
Yeah.
odds ratio. So it is very significant if you look at the confidence interval.
Right.
So,
Okay.
Now this one, we had a little bit of trouble with a chart that we were going to put onto our slide here. Every single time we put it on, it just looked like a giant barcode. Don't know what happened. It would just extend the whole column into one group, but then it'd have all these other blank spots that we couldn't actually get to fit onto our PowerPoint slide. So I have to have Alex explain some of these numbers over here.
Okay, so these are our continuous variables that we use. If I put the class variables up there, all the means are going to be like 1.5 or with diabetes or without it. It's not much of a difference. But age, you can see the older one is if you have diabetes, because you don't. The average for people with diabetes was 59 years old. The average without it is 45 years old. So the older you get, the more likely you are of getting diabetes, probably. This is BMI, and it's really not that much of a difference between having it and not having it. It's 4 points, but the average with diabetes had a BMI of 31.579. Without it, had a BMI of 27.401. I put income up here because it wasn't statistically significant. It just shows you how close the means are between what the average mean. This is a log, so the 9s, the log is their income. And it's with diabetes, they have an average of 9.896, and without it, they have an average of 9.983. So it's not very big of a difference.
Do you want to point out the range of the body mass index
Oh, yeah.
for those with and without?
I didn't write up there, but the BMI has a pretty interesting range. There's a maximum BMI of people with diabetes of 69.7. That's really high. Yeah, I didn't know what that high.
Without.
And then without, the highest one is 66.
Alex, you switched around.
Oh, yeah, just kidding. Yes, I did. 66 has diabetes, and without, it's 69.7. So,
Which was kind of interesting, seeing as the highest number in the body mass index did not have diabetes.
They probably
versus-
had asthma.
That most likely was it.
Probably sleep apnea at least.
So, one more question about BMI, and you may not know the answer to this, but, what is the cutoff? Do you know the guidelines that doctors use for BMI in terms of, normal, obese, and I think it's called morbidly obese?
Normal goes up to 28 maybe.
I think 35 you become more
30,
obese.
yeah,
35.
35 is morbidly obese, and I think obese is 20.
So that-
Or I think they slightly over.
25.
I think 25 is considered normal, 25 shows. 29 is considered normal.
So, no, we did not double check what those cutoffs were.
Well, when you said that a difference of 4 doesn't seem that big, but that crosses a pretty important threshold there.
Yeah. But now that you say that, if you think above 25 is overweight, that means the average of all of them is overweight. It's not good.
That's exactly what I'm saying. Welcome to America.
This is America, I guess.
So this is just some things that I wanted to make sure that we had pointed out. Out of the 9 variables that we ended up using to predict if someone would have diabetes or not, 3 of them were not significant. 2 of those were still, they were getting closer to the cutoff range there, and one was just a really bad variable, that was asthma. But I still wanted to leave it in there just to kind of point out that sometimes you can get in a variable that has almost a 1.0 p-value. It was pretty
I
darn
also
close to
thought
that.
it would do a good job of predicting it, but it did absolutely nothing.
Man, I already did point out family size earlier. It's just one that we'd wanted to see if it would do something or not.
I forget what the conclusion was for family size.
Family size, it was a
It was
significant.
significant,
Yeah.
yeah.
It was .013.
Yeah.
He was saying something.
So which is which? Bigger family is bad? or-
That's what we didn't get.
Okay, so the mean for having diabetes, the family size was 2.7, and the mean with it is, or without it, is 3.0.
So bigger families have
Bigger
less
families have
diabetes.
less diabetes.
It's because you're always fighting.
I guess.
I mean,
Less
that's
food, I mean.
Yeah.
In conclusion, I mean, it's just reiterating everything that's been said. I mean, we used 9 variables, 6 of them were significant. 2 of those were pretty close, that's why we kept them. And then one's the asthma that did nothing. And it's not surprising that income didn't really have a significant p-value.
Well,
Depending on who you ask, I guess. Didn't surprise me that much. 6, also depending on who you ask, could be surprising to some people, could not. But asthma was pretty surprising that it did absolutely nothing to help us in this model.
that's all. Do you have any questions?
For, did you make a model with these 6 variables as well?
Which is the 6 variables?
Just these? Okay.
Should.
I'm going to come back to the asthma thing here a little bit. I'm going to give you a chance to retract this statement that you said earlier. You said, and I want the whole class to think about this. What he said was, if you have asthma, you won't get diabetes.
Now
I wanted to retract that statement too.
It was just a comment that's not necessarily true. You know,
Yeah, now what does that mean though?
It actually
So
means that
correct.
either way, if you have asthma, you have just as high of a chance of getting diabetes as if you didn't have asthma.
You have exactly, so if
Doesn't
you look at the
affect
people
it.
with asthma and you look at people without asthma, they have the same percent of people with diabetes. Almost exactly the
Yeah, I
same.
think it was actually spot on with our data.
Really.
So it was still, I just blanked out, sorry. Yeah, ask a question.
What was the, can you go back to the odds for physical activity?
Because you hear of like a lot of really good athletes still sometimes have diabetes, so I was just curious.
Well, that's the thing, there's type 2 diabetes where you're born with it, I'm pretty sure it's type 2 where you're born with it. And there's just nothing you can do about it, doesn't matter how big you are, your eating habits are.
Did you combine both type 1 and type 2 diabetes?
There was, there was no way of, like,
Yeah.
keeping them away from each other.
Yes. But what I was gonna say about the asthma one is that you still really don't have to worry any more than a regular person, so if you're gonna get diabetes or not.
But yeah, Alan, actually, physical activity, I guess I just said if you do more physical activity. Now, it was, the actual variable was whether or not you did vigorous, mild to vigorous activity 3 times a week. That was their,
So it's a yes, no.
it was a yes, no variable.
Were they all yes, no variables?
No.
BMI was continuous, age
That's
was
right, that's
continuous, and family size was, I guess it was kind of a class. It only went up to 13, but
And income was continuous, and we had to break that down to the log transmission.
So is family size like your immediate family, like in your household?
yeah, it's just parents and siblings.
So then, this question isn't really about the data so much as it is about the naming convention, and I'm not sure if that's even something that was ever mentioned in your original data source, but why is it age 07X?
I think that's just how
Okay.
they set it up.
It was
Just that
the
was the
code
code
that
they
we
used
used.
for it.
Got it, okay.
The codes, I know the answer to that question, but the codes, there's a 3.1, a 4.2, and a 5.3, and then the 07. This was 2007, and they do the MEPS in what they call rounds. So they get like a third of their sample. So if it's 3.1, that's in the 3rd round. I'm not sure. It's over like 2 years, so there's like 5 or 6 rounds over those years. So if you get asked in 1 year, then you're not eligible for participate for the next year, but then, so it has to do with when they were asked.
So I was wondering how they labeled their system.
Well, some of the variables had the 31, 42, 53, and the 07. Some of them only had 31, 42, 53.
Yeah, and I didn't get a good handle why that was either. And the ones with the 07 were the ones at the end of 2007.
Probably their age and 07.
So I told them not to worry about that so much because sorting all that out is a whole semester's project. I mean, seriously. And just so you know, these kind of big national data sets, and you probably have to deal with some of this, there's all kinds of documentation on how this data set was collected and all that. And for a class like this, we just ignore that. But if you're going to really use the analyses and publish papers off of it and try to influence your legislature or something with the results of it, you would need to take into account the way the sample was drawn and get, if they do cluster sampling or they do stratified sampling, where the standard errors are different than what SAS is going to use, and you have to have specialized software to deal with that.
That was actually random.
Yeah, so there's a lot of things we're ignoring for something like this, but, so a lot of this, the rounds and all that, we just lump them together. Any other questions? All right, thank you guys.